look at the topic of the board, statistics, and under statistics we look at probability. Now we looked at statistics in our last class where we talked about data presentation. Under data presentation we looked at different frequency tables. But for today we consider probability. And we say probability is the study of random experiments. It is the study of random experiments. We also say that it is a measure of chance of an event happening or not happening. It's a measure of chance of an event taking place or not taking place. Now, in our day-to-day activities, chances exist for certain things to occur. For instance, we have on the board rain falling tomorrow, a head in a toss of a balanced coin, a student failing a test. Now, from the first, rain falling tomorrow. Presently, it might not be raining, but we cannot say for sure that it will rain tomorrow or not. We cannot say for sure that the measure of chance that it will rain tomorrow or not rain tomorrow is what we call probability. Since we don't have, we're not very sure, very certain that it will rain tomorrow or not. So the measure of this chance that it will either rain or not is what we refer to as probability. Also, a head in a toss of a balanced coin. A head in a toss of a balanced coin. We know that a balanced coin is two-faced. We have the head and the tail. Before it is being thrown once, there's a possibility that we can throw once and get a head, and there's also a possibility that we throw once and get a tail. Now, the measure of chance that we get a head is probability, and also the measure of chance that we get a tail is also probability. So, before throwing once, we cannot say for sure which one we will get. Same is applicable for a student who fails a test. If I decide to give test to a student, it's either the student passes the test or he or she fails it. Now, he or she, the chance of him or she passing the test depends on how he prepares for it. The chance of he or she passing the test or failing the test depends on how he or she prepares for it. Now, if he prepares well, there's a great chance that he will pass. If he doesn't, there's also a great chance that he or she will fail the test. That takes us to sample space. We say it is a list of all possible outcomes of a given experiment. It is a list of all possible outcomes of a given experiment. For instance, we have the toss of a coin. There are two possible outcomes, either the head or the tail. We cannot toss a coin and get any other side aside the head or the tail, so we refer to this as sample space. Also, in the test we talk about, the student either passes the test or fails, so we refer to this as sample space, the list of all possible outcomes of a given experiment. Also, in a dice of a Ludo game, you know that the dice is six-faced and is numbered from 1 to 6. 1 to 6. We refer to this as the sample space because these are the list of all possible outcomes. We cannot throw a dice and get any number other than 1 to 6. We cannot throw a dice and get 7 or say 9 or 15 or thereabout. It's not possible. The numbers must range from 1 to 6. So we refer to this as our sample space. Probability of event. We look at the formula for finding probability. It's given as number of required outcomes all over number of possible outcomes. Number of required outcomes all over number of possible outcomes. Now, our number of possible outcomes refers to our sample space, as we said. We will now apply this in solving problems. Example. Suppose a fair coin is tossed once. Determine the sample space and the probability of getting a head. Suppose a fair coin is tossed once. Determine the sample space and the probability of getting a head. And we say the formula is given as number of required outcomes all over number of possible outcomes. Now, the number of possible outcomes, which is our sample space for a coin, is we have a head and a tail. We have just two possible outcomes, and we are asked to determine the sample space. The sample space is our head and our tail, because these are the number of possible outcomes we can get, and we are to find the probability of getting a head. So our probability of getting a head, we apply a formula, number of required outcomes over number of possible outcomes. Since we are looking for probability of getting a head, the number of required outcomes will be 1, because we only have one head and one tail. So the number of required outcomes will be 1, while the number of possible outcomes, which is our sample space, is 1, 2. We have 1 over 2. Let's go again. We have, suppose a fair coin is tossed once. Determine the sample space and the probability of getting a head. And we say that the sample space is the list of all possible outcomes. If you toss a coin, the possible outcome is either a head or a tail. So we have two possible outcomes. Now the probability of us getting a head will now give us 1, because the head is just 1 all over the sample space, which is 2. So we have 1 over 2 as a probability of getting a head in the toss of a coin. So our sample space is our sample space. Okay, suppose a fair coin is tossed twice. Determine the sample space and the probability of getting at least one head. Now, how do we get the sample space when the coin is tossed twice? Now we have our head and our tail. If we toss the coin twice, the possibility of getting two heads, also a head and a tail and a head, and two tails. So these are the possible outcomes we can get. Either we have a head and a head and a tail and a head, or a tail and a tail. These are the possible outcomes. So we call this our sample space. We can also, we got this by this arrangement. If we do this, this gives us head and head. This two gives us head and tail. We have our tail. This two gives us a tail and a head, and this gives us tail and tail. This and this, we pick these two to get head and head. We pick these two to get head and tail, Then this and this gives us tail and head, while this and this gives us tail and tail. So this is all the possible outcome we can get if we toss our coin 2 times, and this is referred to as our sample space. So having gotten the sample space, we are told to determine the probability of getting at least one head. At least one head. If you check here, you have at least one head. We have 2 heads here, but we are asked at least one head means the least should be one head in each of these outcomes. So we have one head here, we have a head here, we have a head here, and there is no head here. So our probability is still number of required outcomes all over number of possible outcomes. So our required outcome here will be 3, because we have 1, 2, 3. We have heads in 1, 2, 3. All over our sample space, which is the number of possible outcomes, 1, 2, 3, 4. So our probability of getting at least one head is 3 over 4. Let's go again. Suppose the fair coin is tossed twice. Determine the sample space and the probability of getting at least one head. And we say that in tossing the coin twice, there are 4 chances. We have the head and the head and the tail and the head and tail and tail. So there are 4 possible outcomes here. And we are told to find the probability of getting at least a head. We can see a head in the first outcome, you can see a head here and a head here. So the number of required outcome is 1, 2, 3. All over possible outcome 1, 2, 3, 4. So our probability becomes 3 over 4. Alright, another example on the board. If a dice is rolled, what is the probability of getting A, an even number, B, an odd number? If a dice is rolled once, we know that the dice is 6-faced, as we know, ranging from 1 to 6. So the possible outcome, which is our sample space, is numbered from 1 to 6. Now, our required outcome, probability of getting an even number. We count the number of even numbers that ranges from 1 to 6. Okay, we have our number of possible outcomes, which is our sample space. From 1 to 6, so is 6. We count number 1 to 6, we give you 6 possible outcomes. And okay, we have 1, 2, 3, 4, 5, and 6. The probability of getting an even number, we count the number of even numbers we have, 1, 2, and 3. So probability of getting an even number in the true of a dice, we have number of required outcome the number of possible outcomes, and of course our number of required outcomes is 1, 2, 3. So we have 3 all over possible outcome 1, 2, 3, 4, 5, 6, that's 6. We have 3 over 6. You can see that these two numbers have common factors. 3 into itself is 1, 3 into 6 is 2. We have 1 over 2. So the probability of obtaining an even number in the true of a dice is 1 over 2. Also, the probability of getting an odd number. We have odd number 1, 2, and 3. So, you see the probability of obtaining an odd number using the same formula will give us 3 over 6 is 1 over 2. Alright, we have another example on the board. A Jss2 class is made up of 12 boys and 8 girls. If a student is selected at random, what is the probability that the student selected is a boy or a girl? Same process, same formula. Probability of getting a girl. Or probability is given as number of required outcomes all over number of possible outcomes. And we are told that we have 12 boys and 8 girls. 12 boys and 8 girls. So the probability that a student selected is a boy, the probability that a student selected is a boy will give us our number required as 12 boys. We have 12 over number of possible outcomes. And I said earlier on, we have 20 students in the class because 12 plus 8 gives us 20. 12 plus 8 gives us 20. So our number of possible outcomes is 20. We have 12 all over 20. We cancel out 2 into 12 gives us 6. 2 into 20 gives us 10. 2 into 6 gives us 3. And 2 into 10 gives us 5. We have 3 over 5. So the probability of selecting a boy in that class is 3 over 5. Now, the probability of selecting a girl for a boy, the probability of selecting a girl, we have about 8 girls in the class. Using our number of required outcomes is 8 all over our total outcome 12 plus 8, 20. Here we divide 2 into 8, we have 4. 2 into 20, we have 10. 2 into 4, we have 2. 2 into 10, we have 5. That gives us 2 over 5. So the probability of selecting a boy in that class is 3/5, while the probability of selecting a girl is 2/5. It shows that there is more chance of selecting a boy than a girl because the probability of selecting a boy is more than that of a girl. So there is more chance of selecting a boy in that class than a girl. Okay, let's go through it again. Jss2 class is made up of 12 boys and 8 girls. If a student is selected at random, what's the probability of that the student selected is a boy, then B is a girl? And we apply a formula for probability, number of required outcomes, all over number of possible outcomes. And I say that the number of our possible outcomes is our sample space. The total number of students in the class, 12 plus 8, 20. That's our sample space. Now, we divide. Our number of required outcomes will be 12 because we are looking for probability of choosing a boy. So it will be 12 all over 20. And we divide through to get 3/5. So the probability of choosing a boy in that class is 3/5. Same is applicable for the girl. We have about 8 girls in the class. So we divide our number of required outcome, which is 8, by our sample space of 20, 12 plus 8. So we have 8/20, and we divide it to get 2/5. Alright, we have another example. A ball is drawn at random from a box containing 6 red balls, 4 white balls, and 5 blue balls. What is the probability of getting a red, a blue, a white, and we have not blue balls? Now, we first get our sample space. You see the box contains 6 red balls, 4 white balls, 5 blue balls. Now we add this. 6 plus 4 is 10 plus 5, we have 15 balls. Now, what is the probability of getting a red ball? You have our formula probability. Number of required outcome over number of possible outcomes. And we are looking for the probability of getting a red ball. We are told that we have 6 red balls. So the number of required outcome will be 6 because we have 6 red balls. That will give us 6 all over our possible outcome, 15 balls. So 6 all over 15. We divide through 3 into 6 is 2, 3 into 15 is 5. So we have 2/5. The probability of obtaining or getting a red ball in the box of 15 balls will give us 2/5. Yes. The next one, the probability of getting a blue ball. The probability of getting a blue ball. We are told that we have 5 blue balls in the box. So our number of required outcome will give us 5. Because we have 5 blue balls, our number of required outcome will give us 5. So probability of getting a blue ball. We have our number of required outcome all over number of possible outcome. Required outcome is 5 all over 15. So we have 5 all over 15. 5 into itself is 1, into 15 is 3. So we have 1/3. The probability of getting a blue ball is 1/3. The next is probability of getting a white ball. From our question, we have 4 white balls. We have 4 white balls. So our number of required outcomes will give us 4, and our possible outcome will give us 15. We have 4/15. Next is probability of not getting a blue ball. Probability of not getting a blue ball. It means we have the probability of getting a red and a white ball. Since we are referring to the probability of not getting a blue ball, it means we now find the probability of getting either a red or a white ball. So we add our probability of getting a red ball to our probability of getting a white ball. That gives us 6/15 plus 4/15. 6 plus 4 gives us 10/15. 5 into 10 is 2. 5 here is 3. We have 2/3. The probability of not obtaining a blue ball in the box is 2/3. Alright, the probability of numbers ranging from 0 to 1. The probability of an event ranges from 0 to 1. In most cases, it's always a fraction like we've been doing. All what we have been solving for probability, we have been getting a fraction. Now, the probability of a sure event is always 1. The probability of a sure event is always 1. And the probability of that an event, for us to get probability of 0 is for probability of an impossible event. The probability of an impossible event is always 0. For instance, if I say the probability of a dog giving birth to a puppy is 1 because a young dog is a puppy. So it is certainly most likely that a dog will give birth to a puppy, so the probability is always 1. But if I say, for instance, the probability of a dog giving birth to a goat, that is not possible. So in that case, the probability is 0. So I said earlier on, for sure events, the probability is always 1, but for impossible events, the probability is always 0. We have here list 3 events that are sure to happen, list 3 events that are likely not to happen, and 2 examples of equally likely events. Events that are sure to happen, we have the chance that the day after Thursday is Friday. We all know that from after Thursday we have Friday, then Saturday. So the day after Thursday is Friday, so it's an event that will surely happen. We cannot get Wednesday or Tuesday after Thursday, we must always get Friday. So the possibility of a dog giving birth to a puppy, as I said, that's very possible and it's certain to happen. The chance that the month after November is December, that's a sure event also. Now, events that are not likely to happen, you have the possibility of a dog giving birth to a goat, we say it is impossible. The possibility of an apple tree producing a mango fruit, that is not possible. And also the chance of getting number 9 in the draw of a fair dice. We said earlier on that the dice is 6-faced, number from 1 to 6. You cannot get number 9 in the draw of a dice. So it is impossible, and we say the probability is 0. It's an impossible event. Now for examples of equally likely events, I will not write it down, but probability of obtaining an equally likely event, we have in the draw of a coin. Before we toss a coin up, we either have a head or a tail, so it's an equally likely event. You can look for other examples of equally likely event.
Explain.
Alright, your assignment. A fair dice is rolled 100 times. The result obtained are shown in the table below. We have a dice ranging from 1 to 6 and the number of times. Now this table shows that our number 1, we had 12 times, number 2 we had 16, number 3 we had 25, and so on and so forth in the 100 times of the true. We have to find the probability of getting 1